Hello there, Joe Shaw here, incubation engineer in the incubation engineering department at GitLab, working on application performance management, monitoring, observability to try and create our own observability stack within GitLab. This is my weekly demo, weekly update, if you will, issue. You can see the issue in front of you there, and you could subscribe to the weekly list of videos in this issue here. I'll add a new related link each time I put one up. So this week I wanted to mostly focus on the metrics schema work, where I was trying to build a generic schema to capture observability metrics in ClickHouse. While doing that, I quickly realized I probably wouldn't make enough progress to show anything in this demo. So I quickly switched back to running some more benchmarks, which I was going to do anyway with MongoDB and CreateDB. Previously, we benchmarked ClickHouse against TimescaleDB, because that was sort of an obvious competitor for us in terms of having a time series database that was multi-model, flexible, and fit with what GitLab were doing already with Postgres. But out of this selection that I identified as part of the time series benchmarking suite that we're using, MongoDB and CreateDB would be other ones that would fit in with that as well. So the issue here, I tried to run these benchmarks. I managed to fix up, as previously with timescale, well, with ClickHouse in particular, with the time series benchmarking suite, things didn't work out of the box quite how I wanted them to. And I have previous experience with MongoDB, so I was able to sort of patch that up and get that running. CreateDB, unfortunately, I wasn't. There were parts of the Golang interface implementation that were just missing, various scripts that were missing. So I've decided just to drop that. And unless there's any particular objection, I won't be going back to that. So I carried on with MongoDB, and it runs the same as last time. So I've linked back to the previous benchmarks we're doing. It's a VM in Google Cloud, 16 CPUs, 64 gig of RAM, and running the CPU only test suite, because the DevOps one, while it does put more stress on it, it's kind of all relative. It takes a lot longer to run, and we found that the CPU only case was a reasonable subset of the DevOps, the full DevOps cycle one. So to try and speed things up, I ran it with that. So here we go. Here are the results against MongoDB with ClickHouse. So the metric rate when loading the database is much higher again. MongoDB seemed pretty fast, but still ClickHouse managed to beat it there. The volume size is again much smaller, and then we get into the ClickHouse much smaller. Then we get into the queries. The P95, 95th percentile latencies here that we're running, and you can see ClickHouse is performing better initially, and then a lot better, and even better as the queries get more and more complex. And in this case here, the group by order by limit one, which is a very complex query, the MongoDB version doesn't actually timed out. I couldn't get any results out of it for that. And you can see the vast difference there. Again, similar there, similar. And there are a couple where again, single group by is very simple query. MongoDB actually outperformed, but again, we're talking sub 10 milliseconds here in this case anyway. Similar case here, simple. So yeah, in terms of most of the queries, it performs a lot better. We couldn't run the CPU 4000 node test, where that's generating data for sort of 4,000 simulated hosts. MongoDB it would load the data, but querying it was just absolute standstill. And I think it was the memory on the host that was the issue. And then jumping down to sort of CPU and memory usage there. Those are kind of as expected. ClickHouse uses more CPU, but it manages to utilize the server resources a lot better. It's using all the cores to do its work. I found when monitoring it that MongoDB was using far fewer cores, and I don't know if that's a setup issue that I've caused. Although having done some reading, I do think it's something to do with the type of queries being used and their complexity. The actual records that were used in this benchmark do seem quite odd for MongoDB, but I can see that they tried a more naive approach originally, and that didn't scale very well. So this was then the approach that was switched to try and get some good benchmark results out of it. So this is the approach that we're testing against. So in this MongoDB JSON document here, you can see the measurement CPU, the service tags there that we've got for this particular record. So it's kind of grouping it by the unique tag set and the particular day by the looks of it, and then storing all the events, all the CPU events in that day for that tags in this one record. In this kind of strange format where there are lots of empty values, which appear to be the sort of gaps between them. And I guess the idea being then you could just index into this events list. It does make this document in MongoDB very large, and it's clearly not having the best effect on the queries in use there. So not the best solution, but I think we can safely say that we can rule out MongoDB for the time being. You can see that the memory usage of ClickHouse is lower there as well. So that's great. So I'm happy with that. I'm happy to move on now and stop with this benchmarking unless I see any comments or anything that indicates I've missed something obvious. I'll list some limitations here. It's an old MongoDB driver. And like I say, it doesn't utilize all the VM cores, so it might be like a weird connection pooling issue, or the type of queries that the benchmark is running aren't really utilizing the CPU very well. But my assumption has to be that whoever created, the people who created the benchmarks for MongoDB and the document format for it, probably far better suited to do that than I am, and would be better at building a benchmark for it. So I have to assume and trust that that's going to be as good as I could ever create. And I need to focus on getting my ClickHouse implementation done. So back to the issue there. So I'm still working on this metric schema. I've got an ongoing merge request for that. Started with a naive schema, and I'm building the implementation for that just so I can see how that performs in the most basic case before I go on to understand how to refine that and make the queries work better. But it might be that the naive schema works fine. My little tests so far have shown that it doesn't anyway, so that's fine. And our previous weekly issue, we got a very helpful comment in where someone was suggesting improvements to that naive schema. So that's really useful. So one thing I need to do is sort of double check the documentation for various things that have been suggested here, like custom codecs, cardinality of measurements. I looked at some issues to do with, for example, the primary key, and I figured I should sort the primary key an order by case here for at least for the naive one. So I went ahead and used this kind of suggestion for that to try and improve its performance in the most basic case. So it wasn't just really, really bad for no good reason. And I'll look into some of these aspects of this table design. What I intend to do is, rather than having a record being created per field in a measurement, the measurements are all going to end up in the same record using arrays, which has been designed in a lot of other systems as well that I've seen using ClickHouse. So I'm going to have a go at that. Just coming back to the weekly issue then. I also stumbled across the ClickHouse YouTube channel, which I didn't know about, that has some quite useful introductory videos and some useful in-depth videos there as well. So I've been going through a bit of that, which is quite handy to have more of an introductory approach to learning it, rather than looking straight at the documentation, which I have been looking at, but it's not as easy to get into. And the up next is basically the same as it was last week. I need to get back into finishing this metric schema. So that's it for me this week, and I will see you next time.